Hey everybody, it's Jeff, and so I've been streaming every Wednesday for a few weeks now. Um, Mostly writing Go. A couple times I did do some game development. Still considering doing some music production stuff on this stream. I might experiment at a different time with that. I also did a poll to see if people thought it would be better if I did this stream a little later so they could watch it on the West Coast. And so next week it might be a little later. But of course, all these are archived on YouTube. You can go to my YouTube channel. You can also subscribe to get updates when I do the next event. But every Wednesday is pretty regular. Always working on something different, although recently a lot of Go and a lot of stuff related with SSH. The last couple were building JQ as a service, JQ as an SSH service. And I would continue with that, except an older project that I streamed on here, building a 9p network file system Docker plugin. I spent about half an hour of the last part of that stream actually trying to debug an issue that was actually just a missing commit. A friend of mine actually fixed a bug, and I thought I had pulled all his changes, and I didn't. And in trying to reproduce the problem for a blog post, to describe it in a blog post to get help, I actually discovered that, and it fixed it. So the end goal with that 9p plugin was to have a way for Docker to mount remote file systems. Because I'm working on a tool called Command.io. Oh, and I might as well get this out of the way. If you've heard the music on the loading screen or the waiting screen, it's actually the elevator music for a 1993 Super Nintendo game called Jurassic Park, which I recently covered, if such a thing exists for video games. I recreated the interiors of that game and published it on itch, and it's pretty hard and pretty fun. Most of the game development stuff that I've been working on was related to that. Anyway, if you were curious what that obnoxious loop is, that's what it's from. If you get in the elevator in this game, you can hear it in another elevator tune. Anyway, so this is another service that I've sort of been very, very slowly getting ready for wider release. Command.io or Command, which is a service that lets you create SSH commands that you can run from anywhere. And one of its limitations is its only input and output is standard in and standard out. So there's a lot of command line tools that would be kind of cool to put on Command.io and have run in the cloud that do operations on your local files, on your local file system. A lot of stuff. I mean, even one of the use cases for it, LaTeX, right, is designed to work on files in the local directory. There's a workaround where you can just stream stuff into command and it'll write it to the temporary file system, and then it can work with them and spit it out via standard out. But it opens up a lot of possibilities if you can provide these commands access to your local file system. I've wanted to do this for a long time, and then it wasn't until somewhat recently that I kind of stumbled upon this 9p implementation. And 9p is sort of like NFS. It's a simpler NFS, and it's written in Go. And one of the great things is it's already built into the Linux kernel, so you can already mount -t9p, a remote file system here. And so NFS, well, that's pretty complicated and finicky, and there's multiple versions. This is much simpler, and I found this library. The only problem was there wasn't an actual file server implementation. It was pretty much just the protocol and kind of a client. And so, and you don't really care about the client anyway because you're going to be mounting from the Linux kernel. So I wrote an implementation, and a friend of mine who worked on Flynn, who I worked on Flynn with, we submitted some patches to get this thing working, but then so then we have a working client and server 9p. Then the idea was to build the 9p Docker plugin. So I think this is up at Docker 9p. And there's also a whole video on this, and this isn't a README or anything yet. But this is just something that uses the Docker's volume API to orchestrate that mount-t, so that you can basically say, I want to, via the Docker command line, I want to create a new volume, here's the 9p address, and then I want to create a new container, and it's going to mount this volume. And hence get a 9p remote file system in your container. So now that this works, the idea is let's start building a prototype towards what we want to do with Command IO, which is Command IO running as a SSH server that is basically a gateway to Docker and orchestrates running Docker containers and gives you the output over SSH. We would have to provide a custom client that would not only be do the SSH connection, but then run a 9p file server. And then the idea is to tunnel that server, or rather remote forward ports from the server to your client, so that while the client's running, the server has access to your local file system, or at least your current directory. And so that way you can run a command via not plain SSH, but via a command line tool, and the remote command as it executes has access to the file system. So we have the 9p plugin. What we don't have, as it turns out, is remote forwarding in the SSH library that we built. And this library is pretty great for building SSH stuff. It's, I use it a lot. Brad Fitz says it's pretty dope, and there's a lot of great examples in here, but it doesn't do. Someone actually submitted, let's see, local forwarding, although I haven't tested it. But they submitted a handler for doing local forwarding, which I haven't, I just made sure the tests work when I accepted it. So we'll have to look at that to make sure that works. It looks like it does what you'd expect, which is because SSH is just a protocol, and it's actually a really generic protocol. And the port forwarding stuff is just a protocol saying, when you get a connection, an internal multiplex connection of this type, do this. And so in the case of direct TCP, it's saying, when you're the server, when you get a connection of this type, now open a connection to whatever destination host and port. And so it looks that it actually does it, so it dials out and connects them up, and then basically creates a proxy and joins the connections with bidirectional copies. I don't know if this is exactly right, but and actually I don't see any tests. Maybe there are tests, and the test passed, so I'm assuming it works. So now what we have to do is, that's local. So if you recall in SSH protocol knowledge, which you think you know SSH, but do you actually know the protocol? It's mostly the same, but subtly different, and then understanding what it actually means. Again, there's generic channels, and so that's kind of how we set this up, to have generic channel handlers. One of these, if you have questions about this, I'm going to kind of go over it, but if you have questions about, I'm trying to find a particular page that was particularly helpful. But yeah, the naming of the built-in proxy stuff is a little annoying. And I remember it was always kind of hard to remember which one was which, right? What does remote forwarding mean versus local? Because depending on how you look at it, it's one could be the other way around. And then the naming doesn't have anything to do with, at the protocol level, has nothing to do with remote or local. It's direct TCP or forwarded TCP. So direct TCP is the one that's implemented. That's client to server forwarded connections. So that's kind of using it as a gateway. And then we want server to client. As pointed out on Twitter, I don't know if it's actually worth going all the way to Twitter to point this out. And I don't know, he might even be watching. Yeah, criminally underrated feature. And actually, and someone actually submitted an issue because they want this in the library, and they pointed to an example that actually looks a lot like one of my first major open source projects was called Local Tunnel. It doesn't exist anymore. There's a local tunnel that exists that does the same thing with the exact same name. That's not me. That's someone who ripped me off and is kind of an asshole. But it was basically a wrapper around SSH remote forwarding where it ran a server on the other end. And you can imagine how easy that would be to build in Go. Go didn't exist at the time, but that's basically what ngrok became, or what became. I mean, Local Tunnel died out, and then my friend Alan wrote ngrok. There are a lot of other Local Tunnel copycats, but ngrok is the only one I endorse. Okay, we're not looking at Twitter. So that was, and that's using this. So now we have to kind of go and remember how this stuff works. I also know that we have a race condition here that Matt tried to fix. And I don't know if we'll attempt to try and fix that. I guess let's run the test and see if we get timeouts and cancel. That's not what we're working on. Go test the race, I think. And this might be a test that races only on hardware that's fast enough. I don't know. Also, races are not deterministically reproducible, so yeah, I think if there is a test, I don't even know if a test would fail. The idea is we have a server object that in theory you can, let's see what it's calling, config. Config is actually called for every connection. So every time, so it does not seem, it seems like the easiest fix is just to put this somewhere else. So every time there's a connection, it actually resets channel handler. So this is actually a terrible place to put it. And nobody said anything since except for Matt. And he tried to fix it one time when we were trying to work on something else and I told him to stop. So I think the easiest place to put that would be more like on serve, maybe. I think because that's the thing everybody, because there's no constructor new server, and people are kind of wanted an API where people could create their own server object. So listen and serve, yeah. So I think everything ends up calling serve. So we can call it there once, and that would help. I don't expect anybody to call serve twice, and if they do, they can submit a better pull request. But luckily we kind of have this set up already. So SSH has. I wish there was a good. Oh, maybe this diagram. No, this is like a packet diagram. This is not even that useful. Maybe this has a picture. Nope. SSH is a layered protocol, and at sort of once the connection is established, it's basically a transport layer. So no, this is kind of the encrypting and stuff like that, and then user authentication. Okay, no, connection layer. So once transport's set up, it does encryption, you have authentication done. You have a generic multiplexing protocol where it can basically open up sub-connections called channels and handle them in different ways. And so the SSH spec has a number of different ways to handle it. The default, which has a particular name, session, is an SSH shell session or an exec command, and obviously these are the others for forwarding, and then other arbitrary stuff. I'm going to do a stream doing recreating local tunnel, but there isn't actually a generic way to do other protocols yet. So this was the start of that. So we're just kind of hard coding different handlers as we support them, and then eventually there will be a way to add new handlers for other kinds of channel types. So let's actually get in the code. I've been talking for 15 minutes. Feel free to ask any questions. Since this is a live stream, it's good time to take advantage of that fact. Okay, so let's actually create a new branch. TCP. I don't know if I would name it that. Let's see, what was kind of going linearly. So forward direct. Maybe I'll put the forwarded stuff in the same TCP IP file, because I mean both are forwarding. Take this. Okay. So first we're going to take care of moving this guy. And we just put it in serve. So you'd think, oh, you should put a mutex. Oh, it looks like we have a mutex. I think that was added for the listener stuff to drain connections. So I'm not entirely sure why there isn't a lock on serve. So I'm a bit hesitant to add it, but in theory, you can lock. So we'll do that, and we'll run tests and see if it makes a difference. That makes this a little better. And let's forget race testing. Oh, server has no lock. Oh, they put it on. I don't usually do this. I usually embed the mutex in the struct, because it's like, I mean, very rarely do I have multiple mutexes. But that's what whoever submitted that PR did, so I'll just keep following that convention and do this. I mean, in theory, it's good because it's a public function, so it's like anybody could lock or unlock on there, so I get that. It looks like it's running tests down here too. Let's see which one wins. I think my close broke it because it doesn't expect it to be locked during serve because of shutdown locking it, stuff like that. Let's try doing an unlock after this, just so we kind of hint at potentially locking in serve, maybe entirely later on, if it makes sense. And for now, we'll lock just for setting this up. So that seems odd because it doesn't seem to be getting the channel handlers. I don't think those are messed with anywhere else. Yeah, right. This is done on handle connection, which shouldn't be happening until serve. You know what's going on? The serve once is being used. And potentially that's why I did that, because serve isn't actually called in the tests. Instead, this serve once method that only exists in testing. Maybe you can do something like this and just create a method that they both call. And then that can actually have the locks. And there shouldn't be an error, so we'll not expect it to actually do anything else. Now I can actually do the deferred unlock. So that's all this does for now. In theory, I guess to be consistent, we should call it channel handlers. Okay, so in theory, we've avoided that potential race, and now I can move on to the interesting bits. So I just want to review there the local forwarding code. They have a handler, just one method, and a struct. That will be confusing. This should probably be renamed. Direct TCP. Maybe just to help make the code clear, we'll actually call it local forward data. And then the other can use remote forward data. So that we still call things by their kind of protocol reference name, but they have these associated with them. It should make it a little more clear, right? If you ever see this handler and see this, you'd see, oh, local forwarding. Because it's doing test for me, running the tests. Okay. The coverage is not great. That's just running this code though, right? What is the coverage on the whole thing? How do you get that? Is it coverage? Test. Test. Does anybody know? Cover. Coverage analysis, just cover. Yeah, it's not great. The editor's set up to show me the stuff that's not covered. Lots of little stuff here and there. I might have to do that on a stream, just like go through and try and improve the coverage on this, because that's getting pretty low. It's basically an F plus grade. Although our report card is much better than that. It says we have an A plus. Does it not actually check coverage? It seems like a pretty big oversight for our Go report card. Okay. So this is called, we're probably going to have to open up some RFCs soon. It's not that complicated, because we're just looking at the channel, and when you create a new channel, it has a payload, and it's pretty simple. We can go over the direct TCP handler. Forwarded. Now, Go idioms. This is going to bother me. Usually capitalize acronyms. But for TCP/IP, there are a lot of places where that is in here. No place that it actually says in the API TCP/IP. Maybe I will shorten the name to TCP just because TCP/IP is a little redundant. I don't know if you can hear that, sounds mowing the lawn. So there we go. That's supposedly more idiomatic. You tell me. And forwarded. So we now support remote forwarding. We just don't do anything. So this is actually more complicated. The direct TCP is really simple because the client just opens up a new connection to the server, multiplex connection, and the server is just like, hey, I got the connection. I'll make another connection and link them up. Forwarding requires it to do an initial request and then accept or deny, and then it's going to listen, and then any new connections are then going to be sent back. So it's actually a more complicated protocol, unfortunately. Let's check it out. So TCP/IP forward. Do we support that? Client can filter. All implementations only allow forwarding privileged ports if the user has been authenticated as a privileged user. We don't do that. These sound like to-dos that should be included in the code because let's see. Well, we've got this callback, luckily, that they created that allows users to do kind of any policy they want. So maybe it's fine. Should reject these messages normally only send by the client. The client passes 0. I'm pretty sure that'll just work. I'm just kind of reviewing the other one. Okay, TCP/IP forwarding channels. Wait. Oh, this is the request. This wasn't even the channel. A party need not explicitly request forwardings from its own end to the other direction. However, if it wishes, the connections to a port on the other side be forwarded to the local side, it must be explicitly requested. It must explicitly request this. Is it saying that this actually can be used in both directions? Client should reject these. They are normally only sent by the client. Port forwarding can be canceled with the following message. We're not supporting any of these messages. Looks like we only support the forward keys. Actually, maybe that's not true. This is maybe kind of messy. Okay, no. This almost suggests that there might be like an interface to hook in to extend the server library, because a lot of the time you want to handle a channel and potentially handle global requests as well. It looks like the implementation we have ignores the requests, which I guess I don't even know if it works then, but okay, so this is the channel. When a connection comes to a port for which remote forwarding has been requested. Remote forwarding has been requested. Oh, maybe this is the, God, this is confusing. This message is potentially for the remote forwarding, because why would you need to, yeah, okay, this makes sense. Because there's no other request here, right? I was getting confused by the names again. Okay, so it seems to a locally forwarded port, the following packet is sent to the other side. Okay, so assuming, because we don't have a client implementation, so assuming there's a client implementation, connection comes in, following packet is sent to the other side. May also be sent channel open. Yeah, host. Okay, so the client decides whether it wants to do local connections, and then when it does, and when it gets a new connection, it just does a new channel open. This is sender channel. This message type is weird because it's usually this, a string, a channel reference, and then like arbitrary data, but here it's structured data, so it's like you gotta parse that. Okay, so forwarding, resetting. The server will need to handle TCP forward requests and cancel requests, and then call these. Send this to the client. Well, shit. We don't handle global requests. Close, shut down, handlers, serve, handle connection, track connection, discard requests. So we don't even listen to. So we have to change this and then allow a good way to hook in. We might as well design a proper API for it. It's more than a channel handler. It's like a generic. I don't really want this library to depend on component. That's exactly the COM library that I talked about, but that's kind of exactly what this is for. We can at least define an interface, but what would that interface be? This would actually help break down this library into sub-packages. So we'd have a package for each of these handlers. It's a little obnoxious because the API is designed to assume that common case that you want the handler for a server is the session handler's handler. So assuming you get a session channel, this would help simplify this too, right? Because this handler is actually the handler that this session handler uses. I think that'll be fine though. Like it's such a common case, I'm fine with that being. Might want to call it session handler, but it's breaking the API. internal for now. So let's sketch this out. So we're creating an interface. This is a real handler. So this is conflicting with the other one. We'll call it handler for now, which would have at some point handle channel, which looks a lot like this. It is exactly that. And handle channel. I think we want it to. There's two ways you do this. When it's hooked up, it's given the name session direct TCP/IP forwarded, or it can come with its own name, and you just say, register this handler, and then it'll go through each one and then say, oh, you're the session handler because you return session. Here's your session channel. Although that's specific to channels, which is kind of an argument for being part of the interface, because when you register this new generic handler, it might not even have a channel or handler, which suggests this might have to be broken down, because you wouldn't always implement this if you just wanted to handle requests. Although we can just force you to implement this and do nothing if you're handle requests. So then the other thing would be to handle global request, because channels can have their own requests. SSH is like kind of a fractal in its complexity. So handle request, maybe it takes some requests or a request. So this way the system can do the looping and make sure it doesn't block, and call that for each one. Although for simplicity, we probably do want to have it blocked, so we just say that it's a blocking call. So spin out anything that takes a while. We do this. We used to do this, like the session handler. The request that it handles, it just does this in a loop. Session handler, and then it just runs this in a loop, and it doesn't even fork anything off in a go routine, because you get a lot of interesting race conditions, and there were a lot of weird behaviors that were hard to debug. So here it's sort of like TCP, things are done in order, so just like process them in order. So this is session requests, session specific requests. So the idea is we would have a loop somewhere. I mean, in the case of the ignore requests, it actually does that in a go routine. Discard requests just goes through and just listens to that, does a range on it, and does nothing as far as I can tell. Whenever design is involved, it's things move a lot slower. I didn't realize there'd be so many kind of changes here. Let's see. And a request looks. We already have request type. Its payload is sort of arbitrary, but you at least get type of request. So in theory, a handler could specify what types it wants to handle. It'd be nice for the loop to also do this. So a lot of ways to do this. It's kind of the problematic thing here. I need to just pick one. I think I want two interfaces, one for handle requests and one for handle channel. Kind of a lot going on here. Probably gonna need this. These channels sort of like one per. That's not true. All right, let's start splitting those up. These are internal interfaces. These APIs might change. Let's see, so we don't care about the new channel. Server connection. Doesn't the context have the server connection? It'd be nice to simplify this. Context is, I think, has a bunch of stuff. Context has the SSH connection and the server. Why is the server necessary? Server. Oh, because we have stuff, got callbacks on there that are actually specific to the session handler. Otherwise, we wouldn't need to pass the server in. So, but we do have a server in the context, so why don't we make the API just passing in the context, and then it can get the server and server connection out of it. So we're changing some internal APIs, but it shouldn't matter too much. So here they're separate, and instead of coming up with like a crazy, I'm just going to try and do the simplest thing. But what I am going to do is I'm going to change this, so context first. Similarly, context, and then request. And this is going to look like Golang SSH. Where's discard? Oh, look at that. If won't reply. Okay, that makes sense. Oh, we can actually have this return true or false. One thing at a time. Go SSH. It's a pointer. Go SSH request pool. And then move this up here, and we'll actually just call it ensure handlers. We can set up both. And this. These are not that. We'll get to that. I might as well just because I don't want to create an object. I feel like NetHTTP did something weird where they did oh, it's the big package where the handler is actually a function, the implement interface, and then their handle func an adapter. And you know, I thought this was, I mean, this is obviously helpful when you just want to write a function. But in this case, I just want to write a function. I don't want it to create a thing. I thought they had some default some internal thing that used this. But yeah, let's see. I mean, I guess I could emulate this. How would this work though? So you take a regular function and then wrap it in handler func. Whatever, I'm not going to bother with this. I'm just going to create a type. Doesn't matter. Handle channel. And we'll grab these, move this, and then this is context value, context key server. And then this is going to have to be cast type asserted, whatever. And then save this. Although is this server connection that we actually want? Server connection. I think so. You call it a connection, not server connection. I have to double check. Oh, crap. Because there is a connection, and then there's also a server connection which embeds that. You would think that we actually put the server connection in there, is that right? So, handle connection. SSH connection. New server connection does return a server connection. So those docs are actually a little inaccurate. And where were we? Are we still in a server? No. Working on this, implementing this connection. Okay, fixed that. Since this should work now, I should probably try and I don't think I need to do that. channel handler, da-da, and so then it's where we use it, in which we want to say, so until we implement, fix those, we'll just do handler, handle channel. Don't give it either of these. Okay, 172. And 68, what's the problem? It's not an expression because it needs a on the tests also need this. Okay. Test should pass. Nope. But just because we haven't ported those. Okay, so the other two, really just this one because we are going to write this one. Track TCP handler, we need to change this and do the same thing as here. See how I did that? What did I call it though? Whoa. It's not implement channel handler. Wrong type. Oh, because I didn't change this. Okay, so this is one. Do we actually need the server? We do need the server, so we have to do the same trick. Do we care about the connection? The underlying server connection. No, something else. So. And we'll grab see, it's like if they need to get this out of context, there might be something wrong, which is there's too much of a tight coupling, but it's kind of a special case, but hopefully over time we can decouple them more. Okay. Cool. This needs the same treatment. Forwarded TCP handler. Also don't care about that. Shouldn't matter because it's not even being used anymore. Forwarded. Nope. Forwarded. Forwarded. Forwarded TCP handler. What am I doing wrong? Forwarded, like it should be okay, but like, is there a typo? Forwarded and what? Forward. Oh, it's missing that R on the other side. this same handler will have to handle requests. So we can set that up and also implement channel handlers, request handlers, forwarded. Okay, what is the type again? RFC says, actually several of these. See, this is a very weird coupling. I think the handler should specify what it cares about, but we'll do that in the future. What? We don't have request handlers? Or we do, right? Request handlers. Cannot use it. It doesn't implement. Oh, missing key and literal and map or literal. Missing key. What? I'm assuming that's a byproduct of this other one. Handle request. Why not? Nope. Okay, what did I do? 69. Okay. Does anybody see what's wrong? Missing key and map literal. Oh. Hopefully these won't have to be the same instance, but ultimately we'll have to kind of multiplex the handler on these on the other end for now. Do switch request type. Tell me that, right? Case. No piece. Thank you. I wish there wasn't as much of a delay, because then we could actually be a little bit more helpful to each other. Though, yeah, attracted. I appreciate it though. Thank you. If I didn't get it, you would have gotten it for me. And the other one was what? And I suppose return false. So in these, we'll just return true for now. We have to set up the thing that actually calls this. This will be the only one. Request handlers. So instead of discard requests, here we are. So discard requests, call handle requests, I guess. Which will go a lot like this. And It actually look a lot like that. What? If want reply, so first we're going to do another switch. So the initial switch. Or no, we want a loop. I think we want a loop. Do we want a loop? No, we want to do a lookup. Silly. Same as this dealio. If not found, and want reply. And return. No. Continue. Otherwise, we'll do return value will be handler handle wait. This is wrong. Request handlers request type. I don't know. Handle request. Oh, we don't have context. And then if want reply. Potentially there's a return value, I think. Let me make sure. So you have to have the proper like hook API for that. Request reply payload. So potentially there's a payload. So handle request might actually have to do similar return value. And we'll leave those variables in there as sort of self-documenting. Where were we? There we are. So, and then payload, which could be nil. If request want reply, give them the reply. That's pretty good. Just need to get context in here. What's something that has context? Context. I'm pretty sure it's SSH context. Just wanted to make sure it was passed in. Right, context should be passed by value, right? I feel like it's config. No. Oh, because in this particular case, because the SSH context has some special helpers and stuff, we actually you probably pass context around by pointer, right? It can't remember what the normal thing is. All right. So this should work like discard requests if there's no handlers found. Right. So now we can say do that. Oh shit. What now? Server 6.8 literal. It does not implement because handler. Oh, it's just my is this different? Oh, the return type. Whoop. Yeah. True. True and chill. Trill. I'm texting on a stream. That's all. Just that. Handle requests. So, what's its problem? This is the problem. Undefined request. Go SSH. Go SSH. SSH. I have to finish soon. I'm not functioning. So this works. And apparently there's no tests that actually send any global requests. I'm gonna have to split this into 2 parts. Handle requests. Here. Actually, here might be a good place to stop because we've kind of hooked up all the plumbing, we've changed the interfaces and got it ready to just like do the implementation, which is always really nice. Also kind of indicates a decently good abstraction, if I don't say so myself. No, it can always be better. Let's see here. Is there anything else that I want to do? Any questions about this? I'll probably technical questions in terms of I'll probably just do this next week, next Wednesday, which might be at a later time, as I said. Let's see, is there anything else? No, I mean tests are passing. I don't know if anybody wants me to push this up as a branch. I guess I can do that. Do I really want to get into this? It's a good idea. What do we have here? So we'll do context go. Context. Fix documentation to be more specific about context keep con holding or the key for a server connection. What do we got in? What's in the session test? I guess both session and server. Really, all the rest are related to this new handler thing. So just to make sure. I'm just going to add all this and say there. Whoa. I don't know. It's a couple of packages. Which one does it impact the most? I think server. fixes different tense. Fixes the handler setup separated or change to interface based handlers, added global request handlers, handler map, I guess, that works. That summarizes it, right? No implementation yet, but yeah. Remote forwarding. So now the code that we did is up there if you guys want to. I mean, if you want, you could go and finish this implementation. It's sort of like all the stuff that's specific to this project has really been kind of done for you. And you just have to implement these two functions and write tests, of course. And then if I get any pull requests next week, we'll kind of like go over it. If there's any bugs or whatever, then we can fix them. But if nobody submits a pull request next week, I'll finish implementing these on this branch. So that's it for today. Thanks everybody. Thanks Snowpiece and everybody else that's watching. See you guys next week. Bye.